Hello, I'll be presenting to you capturing the environment using photogrammetry to register the built environment for simulation. I am Olavo Neto, and this paper was done with my co-author Marianne Costa Avalone. We have a continuously improvement in measurement and registry of the built environment. Okay, this allows for better and more accurate models. The standard most commonly used method for registry is structure from motion photogrammetry. Registries of the built environment are used for design presentation, for research, and for the design process itself. Different workflows result in different models of varying quality. In this research, we will present a workflow for the creation of LOD3 mesh models, detailed architectural models with openings such as windows and doors. We tested different data collection, registration, and modeling methods, and we provide a workflow based on project scale, types of software license available, and required model precision. A reality capture workflow is composed of data collection, registration, and modeling to generate an output. Data collection can be done using a drone, using a DSLR camera, or even a smartphone. Data registration, we have several softwares, and we focus it on these three: Pix4D, Recap Photo, and Meshroom. Modeling can also be done by a variety of software. The most commonly known are Blender, 3D Max, and Mesh Mixer. Output is normally a 3D mesh model with texture. In this research, we focus on the drone and DSLR camera for data collection, Pix4D, Recap Photo, and Meshroom for data registration, and Mesh Mixer and Blender for modeling. To test the software, we chose three elements varying on complexity and scale: a cathedral, a monument, and an art panel. Data collection. For the tall elements such as the cathedral and the monument, we use a drone to gather data, and we use the free flight since we wanted to capture all around the objects. We have a lot of elements around the objects that did not allow for a pre-programmed flight. So for instance, in this image to the left, you see the monument and all the photos that were captured for the monument. But in this image, we are not showing all the palm trees that are around the monument, and that would not allow for us to do a pre-programmed flight. And for smaller objects, such as the art panel that have a manageable height, we did the data collection with a DSLR and an extension pole. For data registration, we tried a Pix4D that is a professional software, is drone oriented, but has a paid license, so it only allows for a 15-day trial. It has an awesome optimization toolset, and the processing is based on the machine. We also test Autodesk Recap Photo. It has a free version that limits to 100 photos, but it's a pay-per-process license. So you pay for processing one data set, and that is unlimited. It's cloud-based data processing, so you don't need a great machine to do that. You only need to upload the photos to the server. And we also tried Meshroom. That's a free and open source software that's customizable, and also it uses the machine for data processing, so you need lots of space in the machine, and the better processing you have, the faster the process will be. And finally, for modeling, we tested Blender and Mesh Mixer. Both of them have a free version. So Blender is an open source software. It has a wide range of tools, but it has a steep learning curve. Mesh Mixer is very intuitive and easy to use, has a great set of tools also for making geometry manifold. That means it's watertight and allows for 3D printing, and that's very good for modeling assets for architectural simulation. It also has a free and paid license, a full license that has even better tools, but then you have to pay for the license. So what we did, we tested only the standard configuration of the softwares of the free license. And this is the results we had from data registration. So the cathedral, the monument, and the art panel in the Pix4D Mapper, Autodesk Recap, and Mushroom. This is a textured output of the softwares that are being seen on Blender, but we can see that without the texture, so we can have a better understanding of the model itself. We evaluated the models on 6 points. First being cache memory required, meaning the amount of space in your computer necessary to process the one dataset, and Mushroom requires much more space than Pix4D, and a recap doesn't require any space since it's cloud-based. Also the final file size, the textured mesh output from each software. Mushroom has a mesh that's 7 times larger than Recap and Pix4D. We also evaluated the number of triangles. So Recap tries to keep the number of triangles to less than 1 million, and it does that very successfully. Pix4D has a cap of 1 million in the standard configuration, and Mushroom will create meshes that has more than 5 million triangles. From that, we also evaluated how many of those triangles are useful, meaning that those triangles are being used to create the object of interest mesh and not noise or surrounding meshes that are not related to the point of interest. And Mushroom and Pix4D, they have about half of the triangles are useful. But Recap has a way better understanding of what is the point of interest, and so most of the triangles in Recap are useful triangles. Another point evaluated was mesh smoothness. So Recap will create smoother models, which is good for environmental simulation, but not so good for detail, measurements, and registry of the built environment for heritage sites, for instance. And also the detail quality. And Mushroom offered the best detail quality at all scales for city elements. If we evaluated smaller elements, we will get different results. Another point that was very visible in the models are how each software treats voids. So if you have voids in the mesh, Mushroom understood it better than other softwares. Considering the same data, it could evaluate better the voids. As we can see in this picture, in the upper part of the cathedral, for instance, we see that Mushroom output creates the tower voids better than the other two. And the same can be seen in the monument, where we have the voids between the columns, and Mushroom will generate the columns with the voids, whether Recap and Pix4D Mapper could not handle those voids the same way. So looking at the detail of the results in the untextured meshes, we can see the differences between smoothness, between detail, and noise that's incorporated into the mesh. Just remembering that this is the standard configuration. If you have the paid license, or you can process more than 100 photos in Recap, you will get better results than this. The texture meshes. So what we gather from that? For data gathering, you will get better data with drones, especially when they are GPS tagged, and you can use professional software that will use that GPS point to make better, more accurate models. But you can have handheld cameras to provide great data for that. Just have to be sure to overlap, and that overlap of pictures should happen in the horizontal and also in the vertical. That's why extension poles are essential to take a set of pictures from different heights. For data processing, if you're trying to use a free license, go for Mushroom, because it will give you the best detail mesh with a free license. If you can pay for a license, you should try Pix4D or Recap, because they may provide a better mesh, although this was not tested this study. If the purpose is visualization of the model, Recap will produce smoother, lighter models that you can use. But if the purpose is measurements and registering the details, you should use Mushroom, because it will provide a better, more detailed mesh. For modeling, Mesh Mixer is more intuitive and is excellent for smaller projects, but it crashed a lot when we tried to load large meshes like the ones we were working with architecture. So if we have more than 1 million vertices, 1 million triangles, the software has depending on the machine, the software will have a lot of problem to compute and process that, so it will crash often. And Blender is suited for all projects of any scale. Here we can see the art panel model optimized for visualization. And here you have the contact of our laboratory and our personal contact. So if you need anything or you have any questions, I'll be glad to answer them, even if you leave them on the comments. Thank you very much.